So these problems were added for our second round of the progress check review, which is why they were not in the original video. So this is an add-on video for some of these added problems. If fruit flies, the number of fruit flies in the experiment is this function. In weeks, what is the percent growth per day? So I have to ask myself, how many days in a week? That's 7. So to change my model, I'm going to take the base to the 1/7 and the exponent becomes 7t. So now 1.2 to the 1/7 is 1.0264 to the 7t. Population in the county grows an average of 1% a year. This is the current population. Write a model. All right, so population is the initial value, 1 plus r to the t. So I'm going to say t is years, p is population. Simplify your growth rate completely, so I'm going to add this together to 1.01 to the t. Change to go each month. Okay, so how many months in a year is 12? So I'm going to take my 1.01 to the 1/12 to the 12t, where t stays years, that variable is not changing. 5 decimal places, so let's see what that is. This 9 rounds the 2, and that is our answer for B. So now how many quarters are in a year is 4. So I'm going to go back to my original, to the 1/4 4t, still 5 decimal places. Two, 4, 9. 1, 2, 3, 4, 5. Here we go to the 4t. T is still in years. And D, each week. There are 52 weeks in a year. So 1/52 to the 52t. 5 decimal places again. 1.00019. Okay. Number 20 was a new problem. Make a dashed line for your asymptote. All right, so this logarithm got moved down 4. So my asymptote will stay at x equals 0. There you go, I answered the asymptote. The parent function has the key point over 1 and up 0. So since that's going to get moved down 4, 1, 2, 3, 4, that's now over here. So the domain is x is greater than 0. Range is all real numbers. Got my asymptote, and it is increasing from x is greater than 0. Same idea for B. It's going to move my key point up 3. My asymptote is still x equals 0. Domain is x is greater than 0. Range is all reals. And it's increasing for every x greater than 0. Now this function goes left 1. So my asymptote is now at -1, x equals -1, and my key point went from over to the left to 0. Domain is x is greater than -1. Range is all reals. We are increasing for x greater than -1, and my asymptote is x equals -1. This graph goes to the right too. So now my key point is over here. X equals 2 is the asymptote. Domain is x is greater than 2. Range is all reals, and it's increasing for every x greater than 2. Okay, E and F, we've got some reflections. Negative leading coefficient is a reflection over the x-axis. So if I think of my parent function again like this, reflecting over the x-axis is this way. So the asymptote stays the same, my key points stay the same. Now the graph goes decreasing. So x equals 0 is my asymptote. Domain, x is greater than 0. Range is all reals, and now we're decreasing for every x greater than 0. The negative on the x is a reflection over the y-axis, so now my graph's going to reflect over here. Oh, that's a little too steep. Asymptote is x equals 0. The domain is x less than 0. Range is all reals, and we're still decreasing for every x less than 0 because the graph is going down. Okay, graphing the cubics. I'm sorry, cube roots. I'm going to take my argument for f and set that equal to -8, -1, 0, 1, and 8 so that I can get some nice values for my table. So when I subtract 1, I get -9, -2, -1, 0, and 7. So now to evaluate them in the function to get the y value, it's going to be the cube root of -8 minus 3. That's -5. At -2, when I substitute that into the problem, I get the cube root of -1 minus 3. That's -4. When I substitute in -1, I get the cube root of 0 minus 3. When I substitute in 0, we get the cube root of 1 and 7. So now I can plot my points. -9, -5, -2, -4. Connect the points in a nice smooth curve. So a cube root function has the point of symmetry. That's when the argument equals 0. So for this one, it's -1 to -3. Domain is all reals, and so is range. And this function is increasing. All right, let's do that again for G. -8, -1, 0, 1, and 8. Oh, there's a little bit more algebra to solve these. Okay. Give myself some room. I'm going to subtract 3. So I get -x is -11. Divide by -1. So my first value is +11 for my table. So when I subtract 3 over here, I'm going to get -4. But then I have to divide by -1. So my values are here. Now I need my function. I'm going to take all 5 of those values and substitute them, into the equation to get my y's. Plot those points. So 11, 0, 4, 1, 3, 2. And negative 5, 4. And my properties. Point of symmetry is when the argument is 0, right there in the middle at 3, 2. Domain is all reals, range is all reals, and this function is decreasing, not increasing.